Hi, my name is Sangwon Lee. I am PhD student at Yonsei University. Today I will introduce our work, Revisiting Self-Similarity, Structure Embedding for Image Retrieval. We found some drawbacks of the conventional image retrieval systems. In these systems, global image retrieval sometimes fails to consider the structure of an image and is easily fooled by lookalike distractors. This is because conventional global image representations rarely reflect structural information inside the images. In this work, we propose a novel global image representation named Structure Embedding, which can reflect both visual and structural information of the image. Before we go into the details, I will briefly explain a conventional global image retrieval system. Image retrieval is a task that aims to find the same instance images to a core image in a large image database. To perform the image retrieval, we need to convert an image into a compact image representation. I'll describe this process briefly. When a core image is given as an input, the feature map is extracted from input image using deep network, and this feature map is pulled to core embedding. For the large-scale image database, these embeddings are pre-extracted. So, in the global retrieval stage, the searching is performed by calculating the similarity between this query embedding and the database embeddings. So, where is the problem? We found that the pooling operation in this system makes it difficult to reflect structural information in the image embedding. Then, how we solve this problem? We think there are two ways to solve this problem. The first is to replace pooling with a structural consideration aggregation, and the second is to add structural information to the feature map before pooling. We chose the latter of these. In this work, we're revisiting the conventional self-similarity descriptor, and we propose a novel global image representation named Structural Embedding, which can reflect both visual and geometric cues inside the images. Conventional self-similarity descriptors have been used as an effective tool for cross-domain image matching. However, there are some drawbacks to directly using the self-similarity descriptor for image retrieval tasks. First, its encoding process is neither learnable nor differentiable. So, it can be converged with the advantages of deep learning methods. Second, conventional self-similarity descriptor completely ignore visual properties of image. This makes it difficult to use self-similarity descriptor directly for image retrieval because visual properties are also important in image retrieval tasks. To solve these problems, first, we propose end-to-end learnable self-similarity encoder. Second, we propose feature fusion modules that fuse original feature and self-similarity descriptor to reflect both visual and structural cues to the global image representation. Based on the aforementioned design principle, we build a novel image retrieval network named Structural Embedding Network. This figure is the detailed structure of SANet. I will explain each part in more detail. The first part is the self-similarity computation part. In this part, we compute channel-wise local self-similarity for all pixels in the original feature map. The second part is the self-similarity encoding part. In this part, self-similarity encoding module takes the channel-wise local self-similarity as input and gradually encode it into self-similarity descriptor. The third part is the feature fusion part. In this part, the original feature map and self-similarity descriptors are fused into structural feature map. First, we sum up the self-similarity descriptor and image feature map. Here, we add a batch normalization layer with the affine parameters initialized to 0 before adding the self-similarity descriptor. This initializing helps the self-similarity descriptor can be well fused to the original feature map without breaking the original behavior of the base network. Then, the summed feature map feeds to a simple feed-forward layer. This fused structure feature map is finally aggregated to structure embedding through pooling operation, followed by whitening layer and L2 normalization. To verify that our proposed module is producing the intended effect properly, we conduct a visualization using the output of each module. We selected the positive image and the negative image for the query image, calculated the query positive and query negative feature similarity, and visualized it for a single target point X of the query image. Since the similar visual property of target point X exists in both positive image and negative image, both query positive similarity and query negative similarity between their original feature map show high values in some region. However, since the similar geometrical structure of the target point exists in positive image but does not exist in negative image, the query positive similarity between self-similarity descriptors shows high values in the corresponding region, while there are few high values in the query negative similarity. Finally, the original features and the self-similarity descriptors are fused to structural features, raising the similarities where both visual and structural cues form a consensus, and diminishing the similarities that do not. Our proposed SENet shows state-of-the-art performance on server image retrieval benchmarks. Since all the processes of the contributed modules of SENet are pixel-wise operations, extraction latency is in a reasonable time despite the increased number of parameters. Here we show some example retrieval result. Despite advanced feature representation, previous solutions that do not consider the internal structure of images are easily fooled by lookalike distractors. Our proposed SENet captures structural information and reflects them in global embeddings, thereby finding the correct answer more precisely, considering the structure of the image even in the global retrieval stage. In conclusion, despite advancing global image representation, existing image retrieval approaches rarely consider geometric structure during the global retrieval stage. In this work, we revisit the conventional self-similarity descriptor from a convolutional perspective and propose a novel image retrieval network named Structure Embedding Network. Our proposed SENet can effectively exploit visual properties and geometric structures inside the image, which are both invaluable cues for image retrieval, and reflects them to global image embedding. Along with this novel structure embedding, our proposed network sets new state-of-the-art performance on server image retrieval benchmarks, convincing its robustness to lookalike distractors. Please check out our paper for more details. Thank you for listening.